The ice gleams white under a pale Antarctic sun. Then, a slash of rust red cuts through it, not blood but a slow seep, a waterfall of liquid rust, thick as syrup, staining the glacier's face. It flows downward, frozen at the edges, a constant, silent bleed. Imagine this, a river of iron-rich brine, trapped for over 1 million years beneath a kilometer of ice. Now it surfaces. In 1911, Griffith Taylor's expedition saw it first. A geologist hiking across the dry valleys saw the impossible red streak. He named it Blood Falls. Early theories blamed mineral deposits or volcanic ash, but the color was too consistent, too deeply embedded. It flowed like water, not dust. The mystery deepened. Why here, why this color? Decades passed. The falls became a landmark, a quiet enigma. Scientists returned, baffled. The water was unnaturally salty, colder than the surrounding ice. They collected samples. It tasted like seawater, but cleaner, heavier. They found no signs of life in the flow itself. Yet the red stain persisted year after year. Something was generating the iron, actively, something hidden. In the late 1990s, researchers drilled through the glacier. They found a lake, a subglacial lake sealed under the ice for more than 1 million years. No light, no oxygen, just immense pressure and crushing cold. The water, rich in iron sulfates, had been trapped beneath the ice sheet. As it seeped out, the iron met the air. It oxidized, rusted instantly. The red stain was the lake's breath, the slow oxidation of ancient iron. And deep below, microbes thrived, surviving by cycling the iron and sulfur. A hidden world, isolated, breathing in the dark. An analog for life elsewhere, frozen in time. Blood Falls bleeds from Taylor Glacier's face, a slow, crimson seep cutting through ancient ice. The water hits the air, and rust forms instantly, a vivid, metallic red stain bleeding into the snow. It's colder than the surrounding ice, saltier than seawater. You can taste it, clean, heavy, unnervingly pure. This isn't a surface stream. It's water forced upward from a lake sealed beneath 300 meters of ice for over 1 million years. No light, no oxygen. Only crushing pressure and silent, ancient water. Imagine a single drop of this water containing 1 billion microbes, each surviving on the slow, chemical breath of iron and sulfur. Deep below, microbes use sulfate-reducing processes to convert dissolved iron. They pull energy from the iron's oxidation, Phe2 to Phe3, a cycle that powers their entire world. The red stain is this metabolic act made visible. The lake's water, rich in iron sulfates, seeps through cracks in the ice. When it meets oxygen, it rusts. The fall's color is the lake's ancient breath, released after millennia. That lake has been isolated since the last ice age began. No water has entered or left in over 1 million years. The ice sheet above acts like a frozen lid, keeping the lake sealed. Yet the water remains liquid, kept warm by geothermal heat and pressure. The microbes here don't need sunlight. They don't need oxygen. They've adapted to survive on the chemical energy alone, a closed loop of iron and sulfur cycling for countless generations. This isn't just an Antarctic oddity, it's a blueprint for life elsewhere. Imagine Europa's hidden ocean, buried under kilometers of ice. Blood Falls shows how life could thrive in total darkness, using only chemical energy. The red stain on Antarctica mirrors the potential for life on icy moons. It's not a theory, it's a working model, observed in real time. A billion-year secret, bleeding from the ice, proving life can endure where no light ever falls. The red stain bleeds down the glacier's face like a slow wound. Imagine a city block of water, frozen for 1 million years, finally seeping through a crack. This isn't blood. It's iron-rich brine, trapped deep beneath the ice. When it hits the air, the iron rusts, oxidizes, turning the ice crimson. The color is the lake's secret, bleeding out after millennia of silence. Scientists once thought the red could be algae or mineral deposits. But the lake has no light, no oxygen, no nutrients from above. The water is saturated with salt, so cold it should freeze solid, yet it remains liquid. Geothermal heat from the Earth's core warms the lake bed. Pressure from the ice sheet above keeps it from freezing. But why does it asterisk flow? Why not just sit? The lake's chemistry must shift, slowly, over time, to allow a path to the surface. Microbes survive here on a single diet, iron and sulfur. They eat iron, exhale sulfur, then rebuild iron from sulfur. A closed loop, turning chemicals into energy for 1 billion years. Imagine microbial generations living through human history, untouched by sunlight. They don't need oxygen. They don't need food. They only need the frozen lake and the rock beneath it. No light, no air, just chemical conversation in the dark. This is why Blood Falls matters beyond Antarctica. It's a working model for Europa or Enceladus. We see life thriving in a sealed ocean buried under ice, but we still don't know the full recipe. How do the microbes maintain their cycle for so long? What triggers the water to flow now? To be certain, we'd need to drill directly into the lake, but the ice is over 1 kilometer thick. The technology doesn't exist yet. The question remains, what else is waiting beneath the ice?